Today I want to talk about the AWS Solutions Architecting course and specifically about the final Capstone project. This course is really interesting for anyone that is interested in getting into the cloud, and I'm going to walk through my solution to this challenge. And this one is just deploying a PHP application that runs on Amazon EC2 instances in a backend system. It's a very simple PHP application querying just a database for information from database tables. And finally, we're going to extend our solution to a hybrid network, and we're going to migrate a copy of our database to on-premise server and have this backup system. Now, the whole idea of this is to make it highly available, fault-tolerant, scalable, and secure. So I'm going to discuss the architecture in a second here, and we will see how we can create this using AWS. So I've kept all my resources in this repository, so anybody that's interested can just take a look at this public repository of mine. And I've created this diagram of the whole solution. So we have a classic setup with deployed a VPC in this region with a classless inter-domain routing system here using a suffix of 16. And inside we have our public and private subnets, and for our solution we have two availability zones, so we get this fault tolerancy and high availability. Whenever one data center has an outage or natural disaster, we can remain online, our application is still available. And each availability zone has a public subnet, with each subnet having its own routing table, and in this case we have a NAT gateway in the public subnet as well. So this NAT gateway is associated with the private subnet's routing table, so all the backend systems can still securely access the internet through this NAT gateway. For instance, for updates or patches in the database, this is really important. Or if you're bootstrapping your instances here to download dependencies, stuff like that. Now, coming to the actual resources we're using for this setup, we have a application load balancer, internet facing, and this application load balancer is our entry point for users, with its DNS being the entry point. In this case, we are accepting HTTP requests on port 80, and this load balancer is distributing the traffic across our instances, so the target group being the instances in this auto-scaling group. Now, coming to the auto-scaling group, we have configured an autoscaler to scale up from minimum of 2 instances to maximum of 4 in regard to CPU load. So whenever our website is experiencing high usages, a lot of user requests, we are automatically allowing the system to scale horizontally in this case. Horizontally. So coming to the final part here is the data tier. I'm going to come back to the security groups in a second. Just talking about the database, we have Maria database from Amazon. We are using RDS in this case, and then we are going multi-AZ, giving us this read replica and fault tolerancy. The instances, like I said before, are normal instances we will talk about later, and every resource has its own security group, and we are actually giving this a secure daisy chain of trust kind of architecture, where the administrator can access the Bastion host, and only from here we are allowing traffic to our instances, and only from the instances we can access our database. Now, the final part is just the virtual private gateway here, and this we are using to create a VPN connection to our customer gateway. We have 2 VPN tunnels actually, using IPsec v1, and finally we have a normal pfSense router as our customer gateway, which is deployed on a virtual machine, but in this case simulates our customer's on-premise network using a SQL engine. So to basically create the failover. Now I'm just going to go over to my console here, and I want to mention, maybe just quickly going back to the repository. I'm going to mention that I used the infrastructure as code approach to basically solve all of this to prevent click ops, kind of DevOps. Some people call it clicks ops using the GUI, but this is just the proper way to commission all your resources in one go. And you can see I have a template here, and I'm giving it my key name, key pair. For this, I'm using the Capstone key, which I created, so all of my EC2 instances can use this key. I'm also supplying a username and a password. Now, this you can usually put into your system's parameter store, and it's just actually safer there. For this sake of demonstration, I put it here, so not the best security practice, but just to make a proof of concept and make it easier for me, because we can deploy the RDS and our instance in one go. I'll talk about this in a second. Coming to the actual resources, we have our VPC, as I mentioned, with its CIDR block. We have an internet gateway, and we have our subnets, each in a different availability zone specified. And we have our routing tables, public routing table with the reference to the internet gateway. For the private subnets, we also have a separate routing table, and we have a reference to the net gateway. We can see here is the default gateway route to the net gateway to have that secure internet access. Now, coming to the security groups, very important, the Bastion host only open for SSH on port 22, and this usually you should replace with your specific administrator IP address range. For this case, we left it open to SSH access from anywhere, not the best security practice. Load balancer is open on port 80 for HTTP requests from anywhere, like I said, very standard. We have a application security group, so everything. And coming actually to the resources, we can see we have Bastion host running the T2 micro, and we are actually passing the key. So this is in the public subnet also, everything is being deployed. The actual RDS instance, now this is really interesting, it's very important that you specify an identifier. So when we are bootstrapping our EC2 instance in our launch template, we can query the RDS instance and get the endpoint for connecting from the application to our RDS database in the backend. So basically we're allocating 5 gigabytes, and I'm passing the passwords and the username for this database, and we are defining the engine, in this case MariaDB. Now we have our application load balancer as well. It's internet facing, as I mentioned, very normal standard stuff, and we are giving it this target group. This is the target group where the traffic should be distributed to. And in this case, we're coming to the launch template now. Yes, so I can talk about how we are actually bootstrapping our web application here, and we are using Apache to host this basic PHP application, downloading a database file here, and then eventually importing this database file into our RDS database. Now, to actually connect this to our RDS database, we are doing the following. We use the AWS RDS describe DB instance command, and with this command we can supply the ID, which I said earlier, and query for instances, RDS instances in this AWS account, and get the endpoint. So then we store this in a variable, and then we use that along with the username, password, and database name to import some data and connect our application. Finally, the template also allows us to output parameters or values of the resources. In this case, we are outputting the DNS endpoint of the application load balancer. If I actually go to the CloudFormation, we can see that from here, from the stack, we can see the outputs. automatically access the website real quick. Now this is all, I deployed this earlier, so if I go to the Capstone stack here, you can see the description of the template. And here we have all our resources being deployed. And we also have our outputs. So if I open this link, we should be able to access our website. And we can see that's all working. If I query our backend, we should be able to see data from the RDS instance. Now, I can continue, but this all works. And so now, if I go to my instances, actually, let's refresh this page. And here we can see that currently we have the Bastion host and 4 instances running as I was stress testing earlier. So the autoscaler actually works. And if we SSH'd daisy chained from the Bastion host to my EC2 instances. So if I just do an ls here, we can see, or if I do an lsl to our website data, you can see these are in fact the actual EC2 instances running or hosting our website through Apache. And I was using stress earlier here, if you see the history here, to stress the CPU and test the autoscaler. Same for this one. The reason is because I did not turn this one off. It was actually still stressing the CPU. So coming to the instances, or back to the instances, let me refresh them here. Yeah, they are still scaled up already to the maximum amount of 4. Now here you can also see that there are 2 in each zone, so we have A and B, availability zone A and B, and you can see that we have 2 in each, plus the Bastion host. Yeah, so that actually shows that. And finally, I just want to show the VPN tunnel and everything I set up for that. Our virtual private gateway is attached to our VPC, and we can show the VPN connection right here. So we have connected to the virtual private gateway, to the customer gateway using our virtual private gateway. And the customer gateway, in our case pfSense, has this public IP address, and we are connecting through IPsec tunnels. In this case, the tunnels are down. I'm currently at home and not logged into the virtual machine in the ARA network, but I will supply the evidence of this, and also traffic correct. We have correct traffic to the backend system using routing tables. So I'm using the virtual private gateway and routing that to my backend. Maybe I can quickly show that route here. So with this, we can actually have a failover and migrate our database to on-premise server. Routes, go to the route propagation. We have our virtual private gateway down here, and we can see propagation is on. So finally, this actually concludes the presentation, and I believe I've walked through all of my main solutions. I could go on and talk about IAM roles that we're using the lab role here, and this is giving us all the permissions to commission these resources and do the necessary management on them. So in this case, just worth mentioning that the lab role allows us to give an instance profile to the EC2 instances in the launch template as well. And with that instance profile, we have the IAM permissions to use the different AWS CLI commands as well in bootstrapping. So only with that lab role we can actually access our parameter store here. Now this is all nice, and maybe I just show the evidence that the autoscaler, so we can see the activity here. This was from earlier. If I refresh this, we shall see that we are launching new instance, changing capacity from 3 to 4. In response to different desire, actually increasing capacity. So this was just a few minutes ago, and we successfully scaled up due to CPU stress on the instances. All right, that concludes this. Thank you.